This time I operate a vacuum cleaner, but also do many more exhilarating things, although in fact rather fewer than anticipated. To find out what on earth this means, see you on the other side of the intro music. This series is the story of the new amphibious Arctic vehicle project named Bernard. Building on ideas, skills and questions raised during the Allen lifeboat conversion, as a team we will share all those moments needed to get Bernard up north, onto the ice and making himself useful. You'll be as glad as I to hear that the horrible, repetitive, dusty part of the process is in Bernard's panoramic rearview mirror. I started at the top, of course, so as not to redustify cleaned lower surfaces, and really it was the metalwork and ropes that had picked up most of the mess, since the wind movement stopped a layer building on the white canvas. I was even able to deploy the stiff brush attachment for the first time. We are innovating every episode, good people, and making fond memories. Could I have thought through the flooring a little bit more carefully for the dusty phase? Yeah, probably, but this was strangely cathartic. And we have, if not a paint job ready clean room, a pretty tidy one, ready for the next stages. And the next stage is right there. As the hawk-eyed, eagle-eyed, bird of prey-eyed good viewers of the channel that I know you are, you will have noticed that this object here that I teased you with a couple of episodes ago, which is this scored, highly flexible piece of MDF, is not going to become part of the construction of Bernard, of course. It is instead going to be a former. Now, I need to fit a foam core to the majority of this build, with the exception of the nose section, which is going to be solid laminate. But going around some of these radiuses is going to be tricky. The flat sides are okay. I suspect this lightly curved section in the middle will be okay, but this is quite complicated. There are lots of ways of turning foam into a shape that conforms either 2D or 3D with a part. One way is to actually score it rather similarly to this MDF, and then of course you'll end up with air voids in those little V shapes as it goes around the corner, which you then have to fill with something, or you might even leave them as a void. You might fill them with resin, whatever. It can actually end up adding quite a lot of weight to your part. The other option is, if you use a compatible sort of foam, is to thermoform, and you will see completely coincidentally to my left I have a very, very expensive delivery. This is Gurit CoreCell, which is basically the foremost, it's basically the industry standard for impact resistant foam core, and there were a couple of competitors, which both of whom I think have dropped out of the market because they couldn't compete, and so, or at least one of them is very, very hard to get. One of them has been discontinued from other companies, and yeah, I had to get on a waiting list. It's really, really hard to get, and it's exactly the reason why I really need you guys to join as members for this channel, because this needed me to take out another mortgage. Anyway, this is very smart perforated CoreCell, two different densities. I'll explain why in a proper dedicated foam core discussion episode, but yeah, this needs to be able to go from its flat status around here, and this can be thermoformed just over 100 degrees. You'll get it to change shape. So what I'm going to do is make a mini thermoforming oven, because what you can't do is obviously heat this whole thing up, because it will cost a huge amount of money to heat sort of this whole sort of section, but it would also start affecting the MDF and the wooden battens, and the polypropylene probably wouldn't like it. I would end up causing complete dimensional accuracy disaster. So instead I'm going to make a form using MDF, and you might think, putting MDF in an oven, is that a good idea? The answer is yeah. I took some test sections, sort of piece of MDF about that big, I put it in the oven at home, and I put it in at 80 degrees. Put it in there for an hour or two, nothing happened, no smell, no changing colour, literally it looked completely the same. Took it up to 90, 100, this is all in degrees Celsius, 100, 110, 120, I think I got up to 130, still absolutely no effect whatsoever, and so I would argue that this is perfect as a thermoforming mould. And you may think, well, how are you going to get this highly flexible stuff to stay in the shape of this tightly radiused area? Now what I'm going to try and do is try and be careful not to break this. It really is flexible, but it is only MDF. Right, if I do that, so you see how it now comes around the form. You've got all these grooves. Now what I need to do is try and keep it all in place, and you could sort of add battens, you could glue straps in. There are all sorts of ways of doing this. Instead, I managed to get some super cheap as in nearly expired, tubes of high modulus silicone sealant. And what I'm going to do is basically fix this just down with tape to begin with, and then I'm going to squirt all of this high modulus silicone into all of these grooves, really rub it in, push it into all those little voids, and then I'll let it cure. And that should then leave me with, yeah, it won't be 100% rigid, but it'll be pretty damn close. I'll end up with a form which I can then take off, and it will stay in shape, and I can then use that. The silicone will be happy at high temperatures as well. I'll use that in a mini oven that I can make just using OSB board, and pump in heat in there to get it up to 90, 100 degrees, at which point this foam starts becoming pliable. I can then weigh it down, and then I think you leave it like that for a few hours to sort of set into that shape, and then let it cool. And then once it's cooled, it comes out. This should be not exactly perfect, but it'll be close enough to this shape so that a little bit of vacuum downward pressure will bring it into line. If you try to do that radius around here at the moment, it wouldn't snap, but it would be so highly sprung. It will keep on, hello crow, it will keep on wanting to spring back into shape again, and that will be constantly fighting the vacuum that we're going to be applying, and it will make laying up a complete nightmare. So we want this pretty close to the shape that it's going to need to be here. If I take it too tight, as in if I didn't use this at all and sort of formed it around this, then it wouldn't leave enough space for the carbon fibre itself. So actually having it slightly large is probably preferable. I was thinking about just doing 1 metre section, but I reckon I can get away with a 2 metre section. I'll just have to make a slightly bigger oven. I think that's going to work quite nicely. Right, let's do that. Luckily the MDF is scored so deeply and wasn't all that thick to begin with that we can get away with a large sharp knife to divide it into appropriately sized portions. A track saw would have meant finding somewhere to not refill the tent with more dust. 2 1 metre sections in the longitudinal axis, and then wide enough to span the radius, plus a few inches spare on both sides. And yes, it's in the very nature of the English national condition to mix up imperial and metric measurements in a single sentence. Metric for precision and imperial for warm, relatable finesse. First we can lay down the sheets, get them square and tape them down. The natural curl in the board goes the other way around, but obviously we need to get the silicone into the grooves, and so are somewhat committed to grooves up. Never mind, looks fine to me, although it's somewhat sprung loaded under all that restraint. And from the end, the profile looks consistent. As I mentioned, the foam won't need to perfectly match the mould's curve at this point, but as near as possible is the aim. Alrighty, let's get some silicone on there, and I'm just going to hope that it doesn't suddenly spring up. I've put a lot of tape on there. If that suddenly just springs back up, then it will ruin everything. And we don't want that. Okay, this is the fun part. Cheap eBay job lot of nearly expired silicone is deployed and squished in with a gloved hand. So far so good, and I want to really fill those grooves to the bottom so that once cured, the high modulus gunge's presence keeps the MDF in shape. Because that was the cheap silicone, that was not the neutral core, and so I've just been coughing and spluttering my entire way through that. It's the most horrible sort of acidic, nasal assault you could ever imagine. Anyway, I won't die immediately. Still very much alive, more of the silicone mayhem. It's quite fun using the mastic gun with no nozzle on the tube. It means that with about a dozen squirts, the whole content is ejected. However, it's not just one curve over the top. There's actually a reversal in the curve's direction as it approaches the inner edge, and so I need to find a way to uniformly morph the former to follow that shape. A little weighing down does just fine. Not so much though that it deforms the actual mould below. And we'll see how that goes, eh? Will take at least 24 hours to cure properly, and then I can pop it off, sit it on some form ribs of the correct shape, and we can see if it works to thermoform foam core over. In the meantime, I got ahead on the other part of the job and pre-cut some lengths of OSB to make the size of the forming oven. I've measured this so it'll be just about large enough to contain the former and the foam, with minimal space around it to save energy. I've not made a forming oven before, so it'll be a little adventure. Any tips from you guys are welcome. I'm thinking a ducted heater to blow hot air in, a temperature-rated fan to circulate the hot air, and some form of thermometer probe, although I suspect over-temperature won't be an issue. The challenge will be getting the foam to around 100 degrees so it can form well. This did mean I could make some extra dust, which is important, although no angle grinder in this episode. Apologies in advance, and please don't click away in disgust, especially as I'm about to tell you what I could not do. Well, I was supposed to be in this episode showing you a bit of a test spray with my compressor and special resin spray gun, but it started going absolutely crazy outside. This is very much the end of our heat wave, and so instead I think I'll talk to you about my foam and core choices, because I can do that from elsewhere. Hopefully that makes a little bit of sense, but I promise I'll get that spray gun running for you as soon as I possibly can. Right, to that. Okay, let's talk about my core choices. And for those of you who, for some completely inexplicable reason, do not center your entire existences around the pros and cons of different types of composites core, I'll just do a quick explainer as to why it's needed in the first place. If you're going to make a composite laminate out of glass fiber, carbon fiber, whatever you choose, you have a certain amount of stiffness inherent in that part. Now, of course, if you want to make that stiffer and stiffer and stronger, you get to the point where the composite becomes very thick and very heavy. Heavy is a problem because when you're making things out of composites, generally weight is a major factor in that decision-making process. So what you can try and do is separate two sides of the laminate, so a skin either side of a spacer, and that spacer is a core. And you want that core to be lower in density than the laminate itself, because otherwise you might as well just have the laminate and get the strength that you get from the laminate. And so there's always going to be a bit of a compromise going on. Generally, cores are, depending on what you choose, somewhere between 10 and 50% the density of a normal laminate. So you are always going to be saving a pretty large amount of weight. But of course it's never going to be as strong. So you need to look at all the different variations on the market, work out which properties you want more than others, and make a decision. Now, in things like boat building, where weight often has not been so much of a constraint, they've gone for sort of cheap and easy options like plywood, sort of just standard board, which they bond either side to the laminate, and you end up with a not particularly lightweight structure. But for a large boat, that's fine, to be honest with you. But of course, we're looking at much lower weight. And I'm going to show you here what we have, which is basically a very useful set of samples here that I got from Gurit, and they've basically subdivided them by the different families of core type. We'll start with the ones, first of all, that I'm going to dismiss, and I'll give you the straightforward reasons as to why. If you need really high compressive strength, you go for end grain balsa. Problem with balsa, it being a wood, and you can get it in sort of solid form, and you can get it on a scrim form like that, where it can conform to complex 3D shapes in the same way that you can get foam on scrim as well. And it does depend, of course, on which other sort of foam you're comparing it to, what grade of balsa it is. But in general, you're going to be getting something which is reasonably high in density. And there's a big drawback for us, and that's going to be the fact that it has a moisture content. It being wood, it's always going to have a low, but there will be a amount of water hidden in there that, in particular, when you get to cryo temperatures, so we're talking down into the minus 20s, minus 30s, minus 40s, you might get an expansion that can cause failure of the core. So I'm not going to be that keen on having anything with a moisture content for the Bernard vehicle application. But yeah, if you want something with incredible natural compressive strength and also the eco credentials of not being made of plastic, balsa may be an option for you. The other family of cores, which are very popular, but the ones that I've actually discounted, these ones are a type of closed cell plastic foam. These are PET. And although, of course, that just sounds like any other sort of plastic, these tend to have a very high recycled content. And I think they are easier, if you want to take them out of a structure later on, easier to recycle again. So if you do need to tick a load of boxes in on your eco forms, then this might be an option for you. But I've noticed, and I've put together a spreadsheet of, first of all, a long list, and I was trying to narrow down the ones I was interested in. I was comparing most of the mechanical properties, and also, of course, the prices and availability and so on, all the different types of core families, and ultimately these kept on coming up slightly short. So I have discounted PET because, of course, they do have the laudable claim of being partly recycled. I need to go for the maximum mechanical strength in this case and the best bondability. So we are going to put PET foams to the side. They do kind of not dominate the market, but they're very popular. That then leaves us with the two main types I was interested in. These are another plastic closed cell foam option. This is PVC, so polyvinyl chloride, and I think I'm right in saying that these have almost no, or actually I think no recycled content in at all. They're also very difficult to recycle after use, so really if you choose this, it's going to be in your part and it's going to stay there forever, and if you break it into pieces, it'll go into landfill. So there are downsides to it. Also, PVC doesn't burn very pleasantly. I think, although PET probably isn't lovely to breathe in, PVC when it burns produces a lot of toxic nastiness, so you want to avoid setting fire to it. But to be honest, I think that's a reasonable principle to live your life by anyhow. So they tend to have very good compressive strength, good general mechanical qualities, but I was trying to just go one little step further, and I was trying to get to what's known as the impact resistant core foam family. And there were a couple of other options. I think I mentioned them just briefly in the tent a second ago. The first one, I think it was called R63 or something. I'll do a little graphic over to show you what it was. It's now discontinued, and it used to claim to be able to be really good at repeated fatigue and impacts. but apparently no one wanted to buy it. And there's also one that was called Superfoam, but it's really, really hard to get hold of. I think it's still officially in production, but anyway, distribution's a real issue with some of these foams, and often they're on the wrong continent, or the import prices are crazy, or it's the wrong distributor or the wrong wholesaler. Anyway, it's not just a case of walking into a shop and buying stuff. And that leaves us with the one, well, for me it's going to be the winner, and you'll see from the spreadsheet that there's a reason for that. It's the one made by Gurit, which is called CoreCell, which pretty much does what it says on the tin. Got it here in a whole load of different densities, down to a very lightweight 60 kilograms per cubic meter. But then it goes all the way up through 100, 200, all that sort of stuff. But then up to one I had no idea they even thought of producing. This is CoreCell 1800, which is pretty much the same density as carbon fiber. I'm not sure of what applications you would have for a core that's the same density as the laminate itself, but I'm sure there is a reason behind it. It doesn't feel that heavy, but I've done the maths. 1,800 kilograms per cubic meter, so 1.8 tons per cubic meter. And then if you convert that to grams per cubic centimeters, which is generally what you measure laminates, carbon fiber, composites in, that is around 1.8 grams per cubic centimeter, and that is about the density of carbon fiber. So anyway, I'm sure there is a reason why you would have this. It's probably very dimensionally stable and so on, but yeah, it just feels like a solid laminate, as opposed to these, which are even up at the 500 kilograms per cubic meter, which feels, you know, really stiff and really strong. And it feels like a board as opposed to a foam. That's still more than 3 times the density of that. Anyway, it was nice that they included that in their samples pack. And they have it in a load of different types of finish as well. You see that this one has got some shapes in there, and I'll do a close-up to show you what that really means. You can buy foam in plain sheet, which is fine for most wet layups. You simply need to make sure that there's a full, uniform and substantial resin bond adhering the surface of the foam, which is optimized for bonding to the laminate fabric. You can also get resin infusion optimized core, here with channels both sides to let the resin quickly travel along the dry, pre-positioned sandwich of fabrics, and also holes perforating the core so resin can travel top to bottom and wet everything out. Finally, you can get scored foams to aid bending and conformity to shapes. It's offset so that the cuts on both sides don't meet and cause the cubes to separate. You do need to keep in mind though that the slots will end up resin filled, which is dead weight. This method saves the need for thermoforming or for a fabric scrim to keep the blocks together. As we have concluded, we're going for Gurit CoreCell, and I've gone for 2 different densities. Let me find the right ones. There's an 80 and there's 100. It's very common for, if you just go to Composites websites, for densities around 75, 80 kilograms per cubic meter to be sold, and it's a fairly good halfway house for most applications. And we're going for one around 80 and also one around 100. The 80s will be around the sides, which require a little bit less compressive strength, and I'm going for a slightly thicker laminate in that area. And then for the floor sections, the lower parts, we're going with a denser M100, so 100 kilograms per cubic meter, and that will give us slightly more compressive strength. Of course, you could always just go higher and higher and higher, because the higher you go, the stronger you get, but then you get less weight saving benefits. And so it's always going to be a compromise. You've got to find that crossing point on the graph where most of the pros outweigh the minimal cons. That's always what we're trying to be going for here. You'll never get something which is perfect. Anyhow, that's the decision that I've made over the foam. We have plenty of it now, and hopefully over the next few weeks we can actually start putting it into a laminate. Back to the yard briefly for additional lamentation. In addition, I've mounted the gear motor to a large slab of OSB board, which will be a temporary mount for testing, and I was planning to get that wired up today and whirring around in circles, but I bought how many? 5 12-volt 15 amp hour AGM batteries, which I was going to turn into like not a 48 volt, but it would be a sort of 60-ish volt battery, which was going to give it, yes, only about 10 minutes power at full whack, but it would be enough for testing purposes. But the company that sold me the batteries decided to send all the 12-volt batteries charged to only, actually no, with the exception of one, charged to only 5.5, 6 volts, and then had the audacity to claim that they just needed a bit of charging up. A flat 12-volt lead-acid AGM battery is about 12 volts. If you get into the high 11s, you're starting to get a dodgy battery. To have one down at 5.5, 6 volts, I thought I'd originally been sold 6-volt batteries which had been mislabeled, but no, I think they're just really, really old stock, and this complete chancer was trying to flog them to me. And so yeah, BMS Technologies, he's also playing around with the whole returns process as well, because Royal Mail won't take batteries in the post, and so he's claiming that all the postage is my problem as well. So I think we have a little bit of a tussle on our hands, but it wouldn't be a week in the life of my work if it wasn't involving a tussle with a disreputable retailer. But we'll get it done. I'll get it whirring around in circles hopefully by the next episode, which will be super exciting, and I've reordered the batteries from a better retailer. I forgot to say bye. Bye.